Okay. So, hello everyone. Good evening to all of you. I am very excited today. We have a very interesting physicist amongst us, Panchajanya. So, he is right now in IISc Bangalore, Indian Institute of Science. It's the one of the leading universities in the world, and probably the one of the best places to do physics in India. So he is doing wonderful work there. We will learn more about that today. He also is an expert on uh, competitive physics. Like, he has taken quite a few Olympiads. He has also done extremely well in the IIT joint entrance preparation. And even when he entered the university level, he also took some university level contests where he did really well. So we are very, very fortunate to have him with us. And I have quite a few questions for you, Panchajanno. Are you able to hear me?
Yeah, I'm able to hear you.
So thank you for joining us today. Uh, what we will do in the first part of the discussion, we will just have a conversation. And in the
Mm.
second part, we will ask the students if they have any questions. Then they can ask you. Okay. All right. So uh, let me start with a very simple question, Manjujan. So uh, this is a very curious point. I think you had a IIT JEE rank of 348, all in 348.
Yeah,
Is that correct?
yeah.
So you could have entered into any of the IITs for an engineering program, right? Uh,
Mm.
which which people say is pays very well in the long run. So what made you choose physics over that?
So, like, when I was in class 11, since then, my main interest was in physics rather than engineering. I like little bit of coding, but mainly what I like to do with my knowledge of programming is that to simulate some physical problems in computer simulations, like a box of gas particles, or like the gas laws that students have learned in class 8, 9, 10. They all those things I can simulate with my programming. So my main aim was to learn physics, not only do CS or stuffs like that. That mainly because I enjoy physics rather than engineering.
I
So
understand.
that's why I joined a physics program at ISI.
That's fantastic. I mean, it's really inspiring to hear that many talented people are nowadays going back to basic sciences. Uh, did anyone in particular inspire you in your school days or even before that, either in your school or outside school, to
Yeah,
do?
actually, my mathematics teacher, he was very much. He told me to like, it's better if I choose any science-based uh, like academics rather than going to engineering. And I also much more interested in physics. So
I
yeah.
understand. So many students here are actually interested to understand more about how to get started with physics, and what type of books to follow, what type of contests they can take, and so and so forth. And we will ask you all of those questions and understand a little bit more about that. Of course, the courses that you will be teaching at Chinta, those are also mm, those courses are also will reflect some of your understanding about physics. But in general, if I ask you that
Mm.
you have been in IISc for some time, and you are doing some theoretical physics, you're doing some experimental physics, can you tell me about some interesting experiments that are
Mm.
happening at IISc right now, Indian Institute of Science, where which are discovering more stuff about the universe around us?
Yeah. So right now there is a lot of craze about quantum computing and stuffs like that. So recently Microsoft and Google, they all are investing money to develop better quantum computers. Like, go if we go 20 years back, it was just a idea. Right now we have already implemented our quantum computing. There are Google's quantum computer, and there are many stuffs going on. There are condensed matter physics stuffs going on where you study crystals and try to understand various properties like conductivity, magnetic properties, many things you can study. There are many researches around those topics. There are also researches about quantum dots. So basically, if you take same particle but different size of them, suppose you have gold particles and you have various sizes of gold particles. When light bounces back, some of them get some part of the spectrum get absorbed and some part of them get reflected. So you can see like same thing but in different colors. There are also an interesting thing. Also there are
So
some
you're saying that
biomedical.
gold, if I just take gold
Mhm.
and I look at different smaller gold particles and larger gold
Yeah.
particles act differently.
Mhm.
If I make it sufficiently small, is that what you're
Yeah,
saying?
yeah, exactly. So if we go to very small domain, then uh, our what we see classically in our general everyday life, that doesn't hold anymore. So
Right.
we see the same material behave in different ways in different sizes. That's
Right.
one interesting thing. Also, there are many important biomedical uh, aspects of this thing. Like, we can use now nano robots that can go into our into places where doctor cannot like go and perform a
Yeah, perform
surgery.
surgery. Exactly, exactly. Yeah,
So that those are very interesting fields.
yeah,
The
yeah.
field I am currently working is mainly astrophysical in sense. So what I study is that I study gravitational waves and try to understand how the universe was long back, because we might not have like light from like suppose currently known model says that our universe is around 14 billion years old.
Right,
Now around like if we go back in time, very early lights, they are all getting absorbed, or like there are less signals, or like if there is a certain point before which there was no light.
right.
So only thing that we can do to explore those time scales is that we can use gravitational waves, and we can see that there are interesting phenomena, like there were more massive stars than what we see right now. There are many interesting phenomena. So
So
right now
one thing one of my friend was telling me that
Mhm.
when we look at the sun, we actually see the sun how it was 8 minutes ago, because
Exactly.
it takes 8 minutes of time for the light to come from the sun to us.
Mhm.
Similarly, if we look at a far away galaxy, maybe it took 2 million years for the light from that galaxy to reach us. So
Yeah.
basically, we are looking 2 million years into the past.
Hmm.
So what you are saying that maybe a wave is coming. It's not a light wave, it's some other wave, gravitational wave in this
Mhm.
case, which is coming 13.6 billion years from 13.6 billion years ago. And you,
Exactly.
if we analyze that wave, then basically we are looking
Back in
13.1
time.
years back in time.
Mhm.
We actually look back on the past every day. When we look at the sun, we are
Mhm.
actually in a time machine right now. And if we look waves coming for more far away, we are
Hmm.
actually looking farther back in time. Now, what Panchajanya is saying is fantastic. That if we look back 13.6 billion years ago through the waves that is coming from that time, then we can know more about the origins of our universe.
Exactly. Yeah.
Wow,
So
that's awesome. Yeah.
we we don't have light from that past. Like after a certain point, all light that we receive that gets absorbed, or maybe the wavelength gets too broad to like detect by our current telescopes. So
Correct.
what we can do, gravitational wave still gives a lot range of we can go farther back in time using gravitational waves, and
Correct.
you can see interesting phenomena
So
there.
one interesting thing I want to tell the audience, okay, that gravitational waves were detected. I mean, there was a major paper which was published, I
Hmm.
think, in 2016.
16.
Yeah, which went on to win the main authors went on to win the Nobel Prize in physics. One of the co-authors, so that paper had like 1,000 physicists in. I mean, I'm just making up the number. I mean, it's a lot of physicists were there in
Hmm.
that particular team, and one member of that team is actually giving a talk in Cheenta in in the last week of January. Dr. Devnandini Mukherjee. She is right now in NASA. So the audience who are here, I will invite them to that talk as well. We'll send you the link and all, and you can join that. I think that will be a very exciting talk. She will be actually talking about a project called Lisa. So maybe
Hmm.
you've heard about Lisa. She's actually working on Lisa right now. So you can learn more about Lisa, go to internet and figure it out. She's actually working on Lisa right now. So she can tell you more interesting stuff about that. So before I go back to Panchajan, I'll tell you a little bit about the main goal of Chinta physics programs. We want you to get excited about physics. It's not a particular exam, it's not a particular entrance or Olympiad. That's not the main goal. Of course, we want to do really well in those, and as usual, as in mathematics, we would work really hard in physics as well in those things. But the main thing, at least personally for me, I want to get really inspired to do really good physics. And that's only possible if we have people like Panchajanya around us or Devnandini around us who are doing exciting research and figuring out things right now. So that's the main motive of these seminars as well. Panchajanya, I'll go back to you. So
Hmm.
tell me a bit about the Olympiad scene in India. So in physics, of
Yeah.
course, there is NSEP. Can you tell me a little bit more about that?
Hmm. So for those who are currently in like class 8, 9, or 10, they can appear in a junior science Olympiad, which
Right.
takes all the subjects, so physics, chemistry, biology, everything. I'll first go about that. So basically, that's basic science you learn in class till class 10. That's one important. That's a very interesting exam as well. But that's also a foundation to the physics exams that you will give generally in class 11 or 12. So currently, the physics Olympiad in India is mainly into two parts. So first part is NSCP, which is a 2-hour exam, and generally there are around 60 questions, 60 to 70 questions, and 216 marks. So if you qualify for that exam, the next stage is Indian Physics Olympiad, Indian National Physics Olympiad, or INPHO. INPHO is a 3-hour exam, and it is there are very less number of questions, like only 5 or 6 questions, but the questions are very conceptual. So you have to make sure that your basics are very strong. If your basics are strong, you don't need much knowledge about advanced level physics, but you need to make sure that your basics are strong. Then you can start from the fundamental principles and derive every equations you need. And there is sufficient time, but not actually sufficient uh, amount of the time is sufficient, but the questions difficulty level is also extremely high.
Yeah, it's
So
like INMO, in fact, INMO in the
exactly, yeah, yeah.
mathematics domain. So you don't really need to go high, you need to go wide, as Panchajanya rightly pointed out. If you have your basics in the right place,
Mm,
in fact, I would like to say at this point that one of the things we are trying at the junior physics program level at Cheenta is to introduce a lot of experimental physics, like using simulated environments that we do to softwares, and eventually we would also help the students build small labs at their home where they can
mm,
actually perform experiments. Because there is nothing like to physically touch and feel and do experiments in physics and understand the laws and principles that govern our world and universe. So to the students who are listening to this talk, I would strongly recommend that you focus, if you are, especially if you're really young, focus also on the experimental part of physics, because that is also very exciting. Of course, theoretical physics is also very exciting. Many people do that. In fact, one of my friend was a string theorist. He used to work with Ashok Sen. So maybe
mm.
most of you know about Ashok Sen. He is one of the greatest physicists in India, in the world maybe. So you can read more about string theory. But someone told me that to make a string theory experiment, to verify string theory experimentally, you need a galaxy size or solar system size collider or something like that to generate that much amount of energy. So I don't know. Anyway, so continuing, Panchajana, so you mentioned earlier when I was talking to you that
Mm.
info preparation would be also useful for IIT JEE.
Okay,
Is that
yeah. So basically, when you are preparing for INPHO, you are digging deeper into your fundamentals, right? So, and in JEE Advanced, the questions are very, very tough because only due to the fact that the questions are not lengthy. The questions are actually tough in the sense they are conceptually very strong. So if your fundamentals are clear, then it's very easy to complete them. In you also, there is one thing that in JEE you have to perform the entire question in certain amount of time. You cannot give 10 minutes in a question because you have around 4 to 5 minutes per question. So when you are preparing for INPHO, generally the concepts are if you attain the conceptual strength of INPHO level, it's very easy to do JEE problems. Like in my case, I got 116 out of 120 in JEE Advanced, and JEE Advanced is very tough. So I only got one question wrong, and it was yeah, it was one of the highest scores in physics in JEE Advanced. So if you prepare for INPHO, it's very easy for doing JEE physics.
excellent? Can you come? Let's come to the books part. Can you talk
Mhm.
a little bit more about what type of books you will suggest for kids? There is, of course, a separate set of books for absolute juniors, like sixth
Mhm.
grade, seventh grade students. I can suggest some from there, but maybe you can talk about books for NSCP a little bit.
Okay. So for as a starting point, you know that uh, you know about H.C. Verma, right? H.C. Verma is one of the great physicists from India, And H.C. Verma's concept of physics, that book is really amazing. Like it is a starting point for any beginner. It explains all the concepts from very basic level. So even you can even start it even in class 9 or 10. It's you will not be understand able to understand maybe very advanced section of the book, but the basic sections you can start earlier, like class 9 and 10, and then we'll go to slightly difficult domain. So that starts with mainly JEE books. Like you can start with Arihant Publications book, which is authored by DC Pandey, or maybe Cengage Publications, which is authored by BM Sharma, or you can try Physics Galaxy series of Ashish Arora. These three are almost equivalent books, so any one of them will be sufficient, because all three are mainly JEE based books. Once you attain the enough conceptual clarity for JEE mains level, then comes JEE advanced level. JEE advanced level is almost like, similar to Olympiad level physics. JEE advanced is much tougher. So for JEE advanced, the books I'll recommend is mainly Irodov. It's a book by a Russian author, and it mainly compiles all the previous problems from various Russian Olympiads. So some problems are extremely easy, but you have to visualize it. So a great skill will be to visualize the problem beforehand. Then you can solve it in a very shortly you can solve the problem. And some problems are lengthy, but not difficult. So yeah, it's a mix of both types, and it's a very good book. If Irodov is mostly like the ceiling, mainly for us who do till INPHO level stuffs. But after INPHO, there is also opening. Like if you are selected among the top 35 students from India, which then they allow you to do perform experiments on your own in the camp. So I participated in the camp. Unlucky for me is that the camp was online because of COVID during that year. But we have done many like online simulation kind of stuffs in the camp. So mainly you have to also focus on the experimental side, and that is another thing for if you are preparing for physics Olympiads. And
Right.
after that, if you are done with Irodov, you can try Pathfinder of Physics. There is a book called Pathfinder of Physics. This is very recent book, and that's more than enough for any Olympiad kind of thing.
Fantastic, fantastic. In fact, as you mentioned, that a very good grasp on experimental physics from an early age, that could
Yeah.
also be a very interesting part of your journey in physics. One thing that we are trying, Panchajanya, I think I told you a little bit about that, is to set
Mm.
up a maker's lab in Calcutta, where we would create a physics and astronomy kind of laboratory and make some satellite labs in villages in which we work. These will be a non-profit kind of work, but in collaboration with rural schools. But maybe we can attract some really good talent from the rural part of India, which could be really interesting. Anyway, so I think we have covered quite a few grounds. Let me just go ahead and open the floor for questions. Please raise your hand. There is a raise hand tool in Google Meet if you have a question and if you would like to ask something. So there is a raise hand tool. Go ahead and click on that if you want to ask something. Yes, Gaurav Bansal, first question. You can unmute yourself and speak.
Hi. First of all, I would like to thank you for arranging such a talk. It is very useful. Just one question actually regarding the books that you told. They were of a
Mhm.
slightly higher level. Like my
Yeah,
son will be going to sixth in few months. So
yeah.
from the beginning, I just want to ask what is the set of books at this level, so that when they are just getting introduced to physics,
So I'll
so that
suggest a book here.
their
Yeah,
ground.
I'll
Okay.
respond to that question. So there is a very nice book called No Frills Physics. No Frills Physics. This is by Matthew McCluskey. Okay. This is one of the books that we use at our Cheenta beginner level physics Olympiad program. So you can definitely look into that. It requires some algebraic skills, but no calculus to do the problems in physics. So that is one book suggestion. Yeah.
Okay.
But you
Thanks.
have
Thanks.
to add a lot of experiments to the process. That's what we do. Yeah. Yeah. Any
Sir,
other?
can you repeat
Thank
the
you.
name? Can you repeat
Yeah,
that
yeah,
name,
yeah.
book name?
It's called No Frills Physics, a concise study. Okay, I'll just write it in the chat. Okay, so that you can look into the book. It's written by Matthew McCluskey. That's one particular resource that we use. There is another resource that we use all the time, that is called the All Russia Physics Olympiad. All Russia Physics Olympiad for school children. This actually starts at
Mhm.
grade 7 in Russia. Grade 7. So we actually use the grade 7 problems in our junior level physics Olympiad program, the beginner level physics Olympiad program. So what we usually do is we translate those Russian problems into English, and then we prepare our material around that. So it's a complex process, but I can give you the Russian website where you can find these problems, so that if you want to translate it on your own and create material around that, you can definitely do it. I'll send the link to you.